Hello everyone, welcome to Neso Academy. We are learning theory of computation, and in the previous lecture, we have already understood what is a finite automata and how does it process an input string. And now in this lecture, we are going to understand about the block diagram of finite automata. So let's see all the topics of this lecture. Our first topic is the block diagram of finite automata, in which I will explain you the different components of finite automata. Our last topic is the types of finite automata, in which I will tell you about the different types of finite automata. In this section, we will see the classification as well as the sub-classifications of finite automata. So now let's get started with our very first topic, that is block diagram of finite automata. So here you can see the block diagram of finite automata. The finite automata has three major components. The first component is the input tape. The second component is the reading head. And the third component of our finite automata is this finite state control, which is also called as finite control in short. Now let's talk about each of these components. So the first component is input tape. This rectangular structure is called as the input tape. And as we have already discussed in the last lecture, that this input tape is used to store our input string. So this is the input string which is stored symbol by symbol in the finite input tape. Now, this input tape is of finite length. That means it cannot contain infinite number of symbols. And that is why to represent its set boundaries, we have two end markers. This end marker represents the left boundary of the finite input tape, and it is called as the left end marker. It is represented by the symbol CD, which is basically the currency of Ghana. And the right boundary is represented by the symbol $, which is called as the right end marker. These two end markers represent that this input tape is of finite length and it cannot extend in any direction. So this was the first component of finite automata, which was the input tape. Now let's discuss the second component, which is the reading head. This is called as the reading head of finite automata. And this is used to read the symbols from the input string one by one to process our input string. Now let's see the third component of finite automata, which is called as finite state control. This is the most important component of finite automata because in this component, we apply the transition rules to determine which will be the next state on the basis of the current state and the current input symbol. So now I hope you get a basic intuition about the block diagram of finite automata. Now, we will discuss each of these components one by one in details. So now let's start with the very first component of finite automata, which is input tape. This is the input tape of finite automata, which is containing the input string. Now let's understand this. Input tape is divided into squares, each having a symbol from input alphabet. This point simply means that this input tape is divided into multiple cells, or you can say squares, and each cell contains one symbol of an input string. In this way, it stores the whole input string. End markers indicate the boundaries of the finite input tape. These two are the end markers of the input tape, and these represent the boundaries of input tape. I have already told you that in finite automata, this input tape is of finite length. That means we cannot extend this tape in any of the directions. And that is why to represent the finite length, we use the two end markers, the left end marker and the right end marker. Now, as we move further in this course, you will find that in Turing machines, this input tape is of infinite length. That means it can extend in both the directions. But in finite automata, it cannot. The tape is read-only and scanned from left to right, which simply means that this input tape is a read-only tape. That means we cannot write into this input tape. We can only read symbols from this input tape. But in the Turing machines, we can even write symbols into this input tape. But in finite automata, we cannot. Scanned from left to right. That means this input tape is always scanned from left to right. When we do the input string processing, we always process that string from left to right. So I hope input tape is now clear to you. Now let's proceed to our next component, that is the reading head. This is the reading head of finite automata, which is used to read the symbols from the input tape only one at a time. It means that this reading head is used to read the symbols from the input tape only one at a time in order to process the entire input string. In simple finite automata, it reads symbols from left to right. That means, in a simple or a standard finite automata, this reading head can only move from left to right. But there are some special finite automata called as two-way finite automata, in which this reading head can move from left to right as well as from right to left. But it is to be noted that the computational power of a two-way finite automata is also exactly same as a simple finite automata. Now I hope you have understood what is the reading head. Now we will proceed towards our last component of finite automata, which is finite control or finite state control. Finite control is the core logic unit of the machine, which controls the functioning of finite automata. As I have already told you, that this finite state control is the most important part of the finite automata, and it is also called as the core logic unit of the machine because it controls the overall functioning of the finite automata. It manages the current state and determines the next state based on the current input, which simply means that this finite state control applies the transition rules, which tells us that which will be the next state on the basis of the current state and the current input symbol. So I hope finite state control is clear to you. Now we will see how we can process an input string using the block diagram of finite automata. Now you may ask me that in the previous lecture, we have already understood how to process an input string. Then why again? Now there we have processed an input string with the diagrammatic representation of a finite automata. But here, I will show you the actual internal working when we are processing an input string using a finite state control. So now let's start the processing of our input string ABABA. Here you can see that in this finite input tape, each symbol of the input string is stored separately in different squares. And now our finite state control and the reading head is pointing towards the very first symbol of the string, that is A. So assume that we are on the initial state, that is Q0, and the input symbol is A. Now, finite state control will apply the transition rule, and let's assume we will reach the state Q1 after processing the symbol A. So, our next state will become the current state for the second iteration. So now, the current state is Q1 and the input symbol is B. Now, after applying the transition rule, we will reach the next state, which is Q2. So now, the current state is Q2 and the input symbol is A. After applying the transition rule, we will reach the state Q3. Now, the current state will be Q3 and the input symbol will be B. Similarly, we can reach the next state by applying the transition rules, which is Q4. So now our current state will be Q4 and the input symbol is A. We will reach the next state, that is Q5. Now, here our current state is Q5. That means we are at the state Q5, and now you can see that the input symbol is $, which means the symbols from the input string are already processed, and now we get the right end marker as the input symbol. By seeing the input symbol as $, our finite state control will understand that the input string is already processed, and now the processing of input string will be stopped. As we know that an input string is only set to be accepted if its processing ends at an accepting state, which means that if Q5 is an accepting state, that means our input string will be accepted by the finite automaton. But if Q5 is not an accepting state, it means that our finite automata will reject this input string. Now, I hope that you have understood the input string processing in finite automata. And in this way, we have completed with our very first topic, that is the block diagram of finite automata. Now let's proceed to the second and the last topic of this lecture, that is types of finite automata. Finite automata or finite state machines are broadly classified into two categories, that are acceptor or finite automata without output and transducer or finite automata with output. Now, what is acceptor? These automata will either accept or reject an input string. The focus is only on the accepting or rejecting an input string. As we do not get any output string corresponding to the input string, that is why this automata is also called as finite automata without output. And in transducer, it transduces or translates the input string into corresponding output string. That means we are getting the output string corresponding to the given input string, and that is why this automata is also called as finite automata with output. Here, the focus is not on accepting or rejecting the input string. Now, finite automata without output also have three types, and these are DFA, which is deterministic finite automata, NFA, which is non-deterministic finite automata, and epsilon NFA, which is non-deterministic finite automata with epsilon transitions. And transducer or finite automata with output have two types. The first one is the Moore machine, and the second one is the Mealy machine. So these are all the types of finite automata, and we will study each one of them during the upcoming lectures of our course. And in the very next lecture, we will begin with our discussion on deterministic finite automata. So I hope you are clear with the types of finite automata. And in this way, we have completed our second topic, types of finite automata. So these were the topics we have covered in this lecture. This was all from my side for this lecture. Thank you, and I'll see you in the next lecture.